In this video, we're going over minimum size subarray sum. So given an array of positive integers nums and a positive integer target, return the minimum length of the contiguous subarray where all the elements are adjacent to each other, of which the sum is greater than or equal to target. If there are no such subarray, return 0 instead. So in our first example, we're given the target 7 and our input array nums, and then the smallest subarray we can find is 4 and 3, where the sum of the elements is greater than or equal to target. Let's go over the dot process. So we can implement a sliding window approach. We will be keeping track of the current left and right boundaries of our current subarray. So one pointer j will be scanning forward for more elements to be included in our current subarray, and then one pointer I will stay on the left side of our subarray if the sum of the elements inside our subarray is greater than or equal to target. We will need to shrink our current window or the subarray. This can be done by moving our pointer I. We will always move our pointer I if the current subarray sum is greater than or equal to target, because there's no point scanning forward with pointer j if our current subarray already has a sum that's greater than or equal to target, because all of the elements inside the input array are positive integers. Now, we will find the window with the minimum length. Now let's go over the pseudocode. So we're going to create the following variables. The first one is I, our current left boundary. Also the sum of our current subarray. And also min length. The minimum length subarray. It will be initially integer.max value. It's just a very large value in the beginning. Then we're going to iterate through the indices of the input array, denoted as j. This is our right pointer of our window. Then we're going to increment sum by nums j. Now while sum is greater than or equal to target, this means we should not be scanning forward again until we have shrink our window. So we want to update min length if the length of the current window is smaller, because we have found a valid subarray where the sum is greater than or equal to target. Then we want to decrement sum by nums I, because we want to shrink our window. Then we want to increment I. Then we want to return min length if it is not equal to 0, or if it's not equal to integer.max value. Else return 0. If min length is equal to integer.max value, then we have failed to find a subarray where the sum is greater than or equal to target. And now what's the time and space complexity? For the time complexity, we get O of n, where n is the length of the input array. This is our 2-pointer approach. And our space complexity, we get O of 1. Now let's go over the code. So we're going to create the following variables: the current left pointer, the current sum, and also the minimum length subarray. We're going to iterate through the indices of the input array, which is our right pointer. We're going to increment the current sum by the current value. And now while sum is greater than or equal to the target, we have found a valid window and we want to shrink it now, because there's no point of continue to go forward looking for more elements if it will only increase our current sum. Then I want to update min length if the current window is smaller, and the number of elements in our current window is j minus I plus 1. Now I want to decrement our sum by the number on our current left pointer, and make sure to increase the left pointer after. This basically shrinks our current window and decreases our sum. Then we can return min length. So we want to check if min length is not equal to integer.max value. If it's not equal to integer.max value, then it's a valid min length. We can just return min length. Else, we have failed to find a subarray, we return 0. Oh, it's j. Let me know if any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.